I should have introduced myself. I'm Polly Stone, KF7BRO, and we're really pleased to see you all here tonight. I think it's going to be well worth your time and effort to be present for our training. We have a couple of announcements. First of all, our next quarterly training will be on Thursday, August the 8th. So put that on your calendar and plan on that taking place. And KM4QAA, Paul White, we're going to give him a couple of minutes to make a little announcement and presentation here. Go ahead, Paul.
Okay, as everybody knows, there's a lot of general mobile radio service activity going on here. A lot of us log in on Tuesday nights with Steve Galbraith, and it's very effective equipment. The license is just like a fishing license. You pay for it online, and so it's available to a lot of people. But it's a confusing arrangement in some ways. So I've made this is front and back. I've made a reference sheet here that's available to anybody who wants it. Certainly if you're a GMRS operator, if you think you might get GMRS, we'll have it. But on the front in color is a description of the frequencies and the different power levels between FRS, GMRS. And this is laid out in a way with this green on the side to make you look at the frequencies a little differently, because I hear a lot of confusing things said. And on the back, there's some fabulously, world-class artwork here to explain a little bit how line of sight works and some of the combinations when you're using a repeater normally, when you're doing simplex normally, and how things can get very confusing if you have a combination of simplex and a repeater in one communications loop. So anyway, these are available for y'all. I'll set it back here at the table, and after the presentation we can look at it, because I don't want to distract people.
Okay. Paul,
any questions or anything?
Oh yeah, any questions for Paul on that?
So there's a couple of those back there? Or?
I've got, I printed off 100, so I've got plenty for everybody here. I gave some out at the Eagle Rock Amateur Radio Club, and what I want to do is, Steve has a whole list of people for the GMRS net, but geographically they're spread all over. So eventually I hope to get this to all of those people who want one.
Okay, we owe a big thank you to Paul, who has done these, produced these at his own expense and is sharing them with us. So tell him thank you when you see him and when you pick one up tonight. So big thank you. We are going to proceed with our training tonight. And my assistant, Tammy, KG7INX, is going to introduce Steve, our trainer. Thank you, Tammy.
Yep. All right, so Holly gave me a sheet. This is basically Steve's bio and a bullet list. So he is the Idaho Area Welfare Specialist, Idaho Area VOAD representative for the Church of Jesus Christ of Latter-day Saints. He's an assistant to the North America Idaho Area Emergency Communications Response Coordinator. He's the assistant to the Idaho Falls ERC Specialist. That almost seems the same, but not quite. Bonneville County RACES Radio Officer, Bonneville County Aries Emergency Communication Coordinator, Idaho District 6 Emergency Communications Coordinator, Amateur Radio Instructor, and VE, Volunteer Examiner. So with all that experience, I suspect he's qualified to give us some good information. So I'll turn the time over to Steve.
If you believe all that. So I guess to start out with, you might start taking your no-dose. This is going to be a 4 or 5 hour training. If anybody's ever been to my classes before. I'll try to wrap this up, but there's an awful lot of information. And a lot of people say, well, what's a Balun? I've never heard of a Balun before. How many's ever seen this little device? No? Well, I'm sorry. Used to be twin lead plug into this. It's plugged into the back of your TV.
Yeah.
So if you're as mature as some of us are here, that's the way we grew up, right? Actually, we didn't have this. We just put the wires on the back. Flat cable. And so anyway, there's a lot of confusion about different things. And so what I'd like to do is try to confuse you a little bit more and hopefully help some of you get learn the ability to reduce some of the noise on your radio system. And as David here mentioned to me one time, why do I need one? I think it was, why do I need one on my 2-meter radio, my handheld? Well, just for those of you that's all you have, if you turn the squelch down, what happens?
Noise.
You get noise, right? But if you go out into the foothills or the mountains and turn it down, you can go way down, right? So there's atmospheric, not atmospheric, but there's noise from whatever the surrounding area is that's getting into your radio, and that's what's causing that noise. If you had a choke on it, it could go down much lower. I don't know of any chokes to go on handhelds, but that's beside the point. If you have a cable that actually goes to a real antenna outside, you can put chokes on. Anyway, I'm going to just go ahead.
Steve, you got a question?
Yes.
If you put a choke on it, can you do it down at the radio end, or do you have to do it at the antenna end, or does it make much difference?
I do it both places.
Okay.
That's my personal preference. If you stop it up there, you're getting stuff off the antenna, right? And we'll go into a little bit of that a little bit more. And if you get it down by your radio or where it comes into your house, have more chokes. Actually, if you put one every quarter wave or something like that, you'll see that here in a few minutes. That works really good too. Yes.
I'm sure you're going to get into this, but I know a choke is a coil of wire.
Okay.
A balun, though, physically, what is that?
It's a transformer.
Oh, okay.
So we'll get into that.
Okay, great.
Okay, so we know.
Got one other question.
Yes.
If you have a handheld, but you're using a J-pole with a coax in between them, you can then use the choke on that.
Absolutely.
Okay.
Yep, that'd be very, very useful because you get extra gain, and of course you'll pick up a little bit more noise on your cables and things. But then if you choke it down, you're in good
That
shape.
goes back to the question I asked online here a couple of weeks ago, related to that. I was like,
But there's never a guarantee on anything. There's always a gotcha. So we know that radios require 50 ohm input. There's only very few radios that I've ever seen or heard of that are not 50 ohms, and typically they were 600 ohms. Specialty type things or real old ones. So the radio likes a 50 ohm cable. The radio also likes a 50 ohm antenna. And for handhelds, they're sort of 50 ohms, okay? Sort of. We'll leave it at that. So if all else is true, you got a 1-to-1 SWR and everything's perfect, you're getting maximum power transfer between your radio and your antenna. And additionally, all of the signal that's coming back, you're going to get maximum there too, because there's theoretically no losses, right? So it's a good deal. So we're going to talk a little bit about common mode noise. That's what gets on your coax, or well, in this specific case, that's what gets on your coax, and you bring it into your house. And again, filters take care of that. Well, by the way, chokes, they also call them filters, right? So a lot of that's interchangeable. So line isolators, you've seen those little clamp-on isolators that's on the back of your TV or your radios or whatever. Those are awesome. They help a lot. The other thing about line isolators is there's line isolators for 60 cycle, and that's made out of one kind of ferrite material to keep the noise either leaving your TV or coming in, going out, whatever. And then there's for HF, there's a series of ferrite material that you use. I use type 31. If you're running UHF and VHF, there's different materials for that. So those are things that I'm not going to go into. We can do that on a one-on-one basis if we need to later. But I got way too much stuff here. Okay, so line isolators can often reduce the common mode current. Consider the use of an isolator on a coax feed line that's over half a wavelength at its highest operating frequency. And for very long coax lines, they recommend having an isolator every half a wavelength. Here again, coax noise filters are very useful. Common mode current introduced by radiated sources, plasma TVs, routers, anything you got in your house anymore can radiate noise. They all say part 15. They don't They don't interfere with anything, right? Okay. We know better. Anyway, they can pick up and bring in on the braid this outside noise. So line isolators, and I usually have a bunch of them, but this one here, I've taken some line isolators, put heat shrink over them, and there's 4 of them in this particular one. And then I run cable. Sometimes I'll run a cable through it a couple times and put an end on it. And I kind of like this here. But that's a Balun. But it's also a line isolator. Okay. Radio stations is also a key component. They have 2 functions, transmit and receive. So matching the transmitter to the coax line and also to the antenna. If you can't match it, there's a thing called a tuner. How many people use tuners on anything? Okay. Well, all you're doing is dummying the antenna to look like it's 50 ohms, so the radio won't cough and pull itself back. Because if you don't put a tuner on it, the radios, the current new radios are going to fold themselves back, maybe down to a 50 watt or 100 watt radio down to 5 watts. It doesn't want to burn itself up, so it just shuts down, and you don't know it. Okay? This is the way it happens. The alternative is for it to smoke. So we put a tuner in there, and that makes it think it's got 50 ohms. But it really doesn't. But it makes things work, and making it work is okay, because that's what we're after. You just don't have optimum conditions. So matching the transmitter to the coax feed line and the antenna, all that's important. Reducing receiver noise is critical for weak signal reception. We talked a little bit about that already. Using coax noise filters. There's another one that I didn't bring, but I'll show you how it works. This is also a filter. These coils, this magnetic loop here, I buy them 10 at a time. And in this particular situation, you just run the cable through it, and that knocks off some of the noise. Okay? But what I really started to do now, well, here's some small ferrite beads too, is I've started to double them up and build my own. So some of these are chokes and some of them are 4-to-1 Baluns. Okay? And I just make those. Okay. This is the same slide we had before, but I wanted to reiterate that in case somebody came in late. We're trying to get maximum power 1-to-1 SWR, right? Some radios have one connector on the back, and you can see where it has the image up there, says an antenna. Some radios are a little bit more different. They got 3 inputs. Well, now you got to deal with all kinds of stuff. I know Steve has got one with 3 inputs on the back. And so that presents more complications because, well, you can even take those 3 antennas there and go out to a switch and hook each one of those switches up to maybe 4 or 6 more antennas, right? So now you got a lot of stuff that can potentially come in. Very important to start using things like this. So feed line, and I'm sure all of you know all of this, but I'm just going to go over it really quick. So feed line is to get the RF power from your station to your antenna. There's 2 kinds. There's coax and there's open wire. And most of you are all familiar with coax. There's a lot of different kinds. And then this is, if it's this wide of this ladder line, that's what used to hook to these things. So that's ladder line. Some coax is better than other. It has not only a braid, it also has a foil shield, and we'll get into that. So you're all familiar with the center conductor, the dielectric, shield, jacket. If you got questions about any of these things, this is kind of the basics. So you guys can't see, can you? I'll try to sit down. How's that? And see. So characteristic impedance. So it's given in ohms. The symbol is in impedance. Depends on how the feed line's constructed. So we have 50 ohm cable, 75 ohm cable, 300, 450, 600, and there's a variety of others. You can make up different types. So if your radio still wants 50 ohms, what do you got to do?
Step it down.
I'm going to stand up. I can't sit down. So that's what you put a transformer in there, right? On your house, coming in from the street, it's probably, I don't know, does anybody know for sure?
240.
How much? 240?
240.
That's all it's coming down the line?
No, it's
No,
around
no,
12,000.
Coming into the house is 240, but what's?
4160 probably?
No, it's probably around 12,000 or 9,000, depending on the.
Okay, so that doesn't work well on your TV and your stuff, so we have a transformer to change the voltage down. Well, what we're trying to do is change the impedance from whatever the antenna is to what the radio needs. And what does a tuner do? Sort of the same thing, right? Changes the impedance.
Can you tell me what impedance means?
Exactly what it sounds like. It impedes the flow of electricity.
It reduces.
I can, but I'm not sure we want to do it here tonight.
Okay.
Now, do you know what inductance is? Do you know what capacitance is?
Yeah.
Okay, so inductance and capacitance, if they're matched, you can make it look like it's a 50 ohm system. So I hope I'm doing this simple enough that you can understand it, but not. Anybody else understand it? Yes.
Resistance applies to pure DC. When you go
Yes.
to AC, the intellectual equivalent of resistance is impedance.
Exactly.
But it varies with
And it
frequency.
Z is a symbol for impedance. So we'll come back to that
It becomes much harder.
a little bit. So that's something you deal with
The
HS.
slide's going to be available soon.
Pardon?
Are the slides going to be available? Can you post
Oh,
those
I could
slides?
probably do that. He's making a video for us.
Well, yeah, if you post the slides on the web page, that would be great.
Might have to take all the lies out of it. Yeah, we'll make them available. Okay, so we talked about ladder line, and there's coax, and there's all kinds of coax, from cheap coax to better coax. And some of the coax that I use, the center conductor is hollow. It's a copper, quarter-inch copper tube. Okay? RF travels on the outside, right? Don't need the inside, it's just extra weight. And the impedance of it, the resistance, if you will, the impedance is still 50 ohms, but the resistance in the cable is, instead of having maybe 3 dB or 5 dB per 100 feet of cable, this maybe have 1 dB or half a dB, depending on the cable. Awesome stuff. Okay. So most feed lines use coax cable, and the reason for that is just easy to deal with, right? And if you've ever worked with ladder line, it's a pain because eventually you put it in a balun and put it into a coax anyway to get it to your radio, regardless of how you look at it. So open line wire or ladder line is another common name for it. It's lighter, less expensive, but you got to have an impedance matching device. In other words, you got to change the impedance from 400 or 600 or whatever down to 50 to make it work. Okay, standing wave ratios. SWR, right? Just leave that at that. So you want to match your radio to your cables to your antenna. So the signal going up, that's coherent. That's a wave going up. That's going off around it is not. That's destructive interference. That ends up making heat. It's out of phase. It's destructive. Kind of an interesting picture, but anyway. So if you've got a bad cable or the impedance is not the same, the wavelength is going to go out and hit wherever that connector is, or like an antenna or whatever, and it's going to be reflected back. And that burns up radios or heats your cables or causes your radio to reduce the output power. Okay? Make sense?
Or takes out your semiconductors in the radio.
Pardon?
Or take out the semiconductors in
That's the
radio.
burned up radio part. It's the finals. If you got tube radios, they can handle it a little bit better.
Till the glass melts.
Pardon? Yeah. When they melt down, you know you got a problem. Okay, so nothing's perfect when the SWR, and I don't agree with this, but it says when the SWR is 3-to-1, it's considered high. I would never operate a system with 3-to-1. I won't operate a system with 2-to-1. I like to keep it down around 1 to 1.2 or 1.5 or better. But that's what's out there is published. And by the way, a lot of the information was either taken out of the ARRL training manuals that I've done in the past, or other things online that I've pulled information from. But it's all supposedly good stuff.
Question.
Yes.
SWR changes with make change frequency. You're trying to get as low as you can, but sure you can get it low, but you change frequency up a little bit, not too far, and then the SWR is going up.
What? I never heard of that before. Did you understand what he said? I hate to do this, but
So it's hard to keep it under 2.
let's say here's where you want to talk, and your radio is like this. And you're here, but you all of a sudden want to talk over here. In this part of the band.
SWR is up higher.
And now the SWR is 1-to-1 here. It's maybe 1 to 2 here and 1 to 3 here. And so now you want to talk here because that's where your friend wants you at. Yeah, there's different problems. So that's another thing for a tuner. You can have your tuner, and I'll show you some pictures of some tuners and things, but you can have your tuner track that, and that helps.
I've always felt like it's best to get the SWR in as closer to the neighborhood as you can. Then your tuner is a lot more effective and doesn't waste as much.
Exactly. The other thing too is if you know where you're going to operate, you can set your Balun up a little bit to try to help make sure it's 1-to-1. You're using a 4-to-1. Here again, depending on the height of your antenna, also makes a difference. Length of your wire, where you located it, what kind of ground you've got it on. Everything affects everything, but you do the best you can. Okay, so you either adjust your SWR, or the SWR meter's inserted in the feed line. You either adjust your antenna to minimize the reflected power, which is always the best thing to do. Put it where you want to operate. I don't believe in going up there and changing it every day or every time you want to change frequencies, but it needs to be set where you're generally going to operate. Otherwise, you're going to run into issues. Yes.
So this would be more for like a more permanent radio than like a handheld.
Exactly.
Okay.
Yep. However, as you'll see, there are SWR meters that you can put on the end of your handheld and then put your antenna on top of it just to see what it does. And many years ago, I don't know if in the club, when I was a club president, we had, I think it was every year, we'd take handhelds out, put an SWR meter on them, put our antennas on them, and see whose antenna was actually even close to being 1-to-1. And what we found is, back when we first started doing it, there was not a store-bought antenna that come with a radio that was worth a hoot. So we called them rubber ducks and we put them in the garbage. Now I have to say that in the last 20 years, pretty much everything I've tested that comes with a radio that's of any value, they're right where they should be, okay? So if you've got you a Yaesu or a Kenwood or ICOM, something like that, those antennas are solid. I can't talk about those other
Things.
radios. Because I've seen what they are. I've got some. I know what they'll do. Some of them work, some of them don't. Okay. Okay, so the SWR meter on the left, you can actually take that little puppy and put the right connectors and stuff on it, and you can put it on your handheld. The one on the right's for a little bit bigger radio typically. This is a tuner. It's an automatic tuner. And I have one like this in my setup for my amp. Yes.
So what are the advantages to like automatic tuners versus like a manual tuner? Because I know like as automatic you just have presets and it clicks and does its thing, or you just press a button and it does it all, or how does that all work?
All I do when I'm running my amp and I use my tuner like this, when I do a tune on it, it'll automatically set itself. But if I don't think it's close enough, I can hit the tune button there, and it'll go out there with like maybe 5 or 10 watts, and it'll bounce around a little bit and it'll set everything up even closer. But they do have memory in them, and they do try to get it back to the same place that you operated last time. But how many of us will get on a net and we're supposed to be on 3810, right, on Sunday evening? And we've moved the net to 3815 or 3818. Well, you're not exactly perfect again. But if you want to play that game, you can go back and hit this. Now, the other thing is you can also get antennas that are pretty flat from, say, 500 kilohertz to 60 megahertz. Okay? They're a little spendy, but they work. Yes?
If you train your automatic tuner, then you don't have to hit the tune button every time you change frequency.
Exactly.
And in order to train it, if you don't know how to train your tuner, put your radio in the AM mode at 5 watts on a dummy load and key your radio every 25 kilohertz from the bottom of the band to the top of the band that you want.
Dummy load.
And that will train your tuner, and whenever you change frequency, you don't have to mess with the tune button anymore.
Exactly. Now here's a manual tuner. On a manual tuner, to answer your question, you just play with it till you get it. You know about what the numbers are, but they're sometimes a little different each time. What that is there's a bunch of inductors and capacitors back in there behind them knobs. And so that's what you're adjusting. But it does have a meter on the front to tell you where you are. Now let's see if the last one. Mine actually has a meter where it said, well, not I do. One of my LGs have a meter. This one here's got the meter where the little lights are. So, and you can put 2 antennas on it. Okay, so let's talk a little bit about antennas. So whether it be a horizontal antenna or vertical antenna, and that could be a handheld, the vertical one on the right, still an antenna. And so there's always one side of the antenna and the other side, right? Where's the top and the bottom of the handheld?
The top is the antenna and I'm the bottom.
Bingo. Okay? So it still has both parts. So, balance stands for balanced to unbalanced. Antennas are balanced. And let's just go back there. If you've got noise coming into an antenna or signal or whatever it is, it hits that antenna, the whole thing at the same time, right? You don't agree with me?
Well, it had different parts depending on the angle of the...
Yeah, but it's still going to hit the whole thing.
Eventually. Yeah.
Yeah, it depends on how you're breaking it down into picoseconds and nanoseconds and stuff.
Well, you're thinking, I'm just thinking like math, this is just my brain works.
No, that's okay. That's okay. Yes.
Electrical noise will be kind of like light. It just comes from every direction, right?
Exactly.
Whereas a signal comes in from a certain particular direction.
most typically. However, there's mountains and clouds.
You could have multipath.
Exactly. But, so where am I going? Okay, so the antenna is it's a balanced system, okay? It's like ladder line. Where'd I put the ladder line? Any noise in this building or coming in from wherever is gonna hit both wires at the same time, right? Relatively speaking, for her.
Tiny, tiny fraction of time.
Yeah.
You're down to picoseconds of time delay between. 9 inches, 1 nanosecond per 9 inches, okay? I know that. So, we also know that coax is unbalanced because outside interference will hit the coax shield, right? Is it going to hit the center shield or the center conductor?
Not so much.
Nope.
Your shield if you just not.
So now it's unbalanced. The shield has noise on it, the center conductor doesn't. So, baluns again take many different forms. May transform impedances from say 400 or to 50 or 100 to 50 or whatever. Could be from 10 ohms to 50 ohms. Sometimes they're magnetically coupled. This is almost all of them are magnetically coupled. But here's an example of a magnetically coupled. That's 18 to 1 balun. And I put a resistor out here and I can fire this up and it'll tell me. It actually turns out to be 50 ohms on the end over here. Okay. So again, a balun's a transformer. For all of you probably remember when you were doing your DC circuits and stuff like that, that you had 115 volts coming in on one side and you needed, what, 25 in order to get 12 on the other side? So you have a transformer to change and it's a ratio of number of turns on one side versus number of turns on the other side. Okay, well, here's what's in a balun. And I apologize for not using colored wire in here. You can actually get colored wire that's, it's a Teflon coated wire for high power, high temperatures, but it's a bit pricey. This wire here is actually, I went over to, if you know where Teton Communications is, there's a place over there that rewinds irrigation motors. You know, the great big 500 horse motors and stuff. This is the wire that they use for rewiring those motors. And you can buy it by the pound over there. So I bought a few pounds. So, but pictures are really neat. When you assuming all you guys are going to start building baluns, take one wire and follow it where the red goes. And take the next wire and put it where the purple goes, and it makes it a lot easier than trying to do them both together. But after you
Say that again, please.
Wire one first. and wire the other
Don't
one
try to
later.
put both loops of wire, the purple and the red, together
On
on some of them.
Wind both wires at the same time. Wind one wire at a time, only next to each other.
So I've got 3 wires that run together on this one. There's 3 wires for each that go in pairs, or well, it's not a pair anymore. It's a
Triplet.
whatever it is. And they come out at different places and do different things. And you can find yourself trying to figure out what you did and pulling the wire out and trying again. Okay, now there's another term I'm going to introduce to you, and it's called unun. Okay, anybody know what an unun is?
Unbalanced, unbalanced.
Pardon?
Unbalanced, unbalanced.
Balanced to balanced?
Un-
Unbalanced to balanced.
Unbalanced.
You read the thing over here, didn't you?
Yes. No, I didn't read the thing. I just saw the term and I figured out what it was.
Okay,
Well, I didn't
so
look
this is a
down there
4
and
to
see
1. This is where you're going from, say, an antenna that is 600 ohms, and you're going to use 450 ohm ladder line. So you'd use a balun like this, or an unun, excuse me, which does the same thing as a balun, but it's for unbalanced. Unbalanced. No, let me rephrase that. It wouldn't be from cable. It'd be from.
Coax.
Coax to ladder.
Pardon?
Coax to ladder. Like your first example, you showed us the old TV.
Yes, 75 ohm cable to 50 ohm cable. Yeah. That's what I got written someplace. So if you're going from 75 ohm, because some people use 75 ohm cable for a lot of things. I don't recommend it because it gets tangled up with other stuff.
So when you're building the ununs and the baluns, does it matter on the secondary side of your balun or unun, which side is the ground and which side is the transmit? Does that make sense? Or?
Yes.
So is that in the diagram generally that you'll be able to see that? Or?
Yes. See the connector here?
Because I noticed, yeah, it has the center to the coax, but in other words, the blue and the red up top, those matter on which side of the antenna to go on. Does that make sense? That's my question.
No. These two can go on either side.
Okay, so those side, it doesn't matter,
No.
just on the primary side.
I've had people tell me one's positive and one's negative, and I'm saying, would you explain to me what positive and negative is on an antenna? And a good friend of mine, who I bought a lot of baluns from, mini baluns from, he actually stamped on some of them positive and negative. And he said he did that specifically for the idiots. Because they couldn't wire it up unless they had a positive and a negative. So they were always calling him and, anyway. So, yeah.
They learned that through jumpering cars.
Pardon?
They learned that by jumpering a battery in a car.
Exactly. Or the radio. So, okay, here's a little bit more vivid pictures of you can track those a little easier. This is a 2-to-1 balun. And what it is, it's a ratio of turns, right? So there's twice as many red ones as there are black ones. Okay? This material here is, it's not ferromagnetic, but it's, maybe for the sake of this meeting, I'd say it's ferromagnetic. It's a magnet. Okay? Only it doesn't have iron in it. And it's not magnetic. But it won't stick to anything metal, okay? But you run signals through it and it'll knock down the noise in a big time. Same thing with the baluns and whatnot. Okay, now here's another version of, and you just got an input and an output, and I've put these in tubes. And these are just 3 wires wrapped together around this. There's so many of the wires, they start and stop and come out, and there's some goes through the middle and some goes over the top, and they kind of, but they work. And what it does is it causes, it's just like having a big resistor to that noise to knock it down, high impedance to the noise, but it has no effect on the signal going through it. Okay? Well, I'd never say never, but yes.
So I'm going to sound really ignorant with this probably, and that would be appropriate, I am. Do all antennas, or should all antennas have a balun, or how do you know if you need one? The laugh doesn't help my confidence anymore.
I started putting all my antennas up not knowing what a balun was. And then I got educated by the gentleman's gone now, but his name was Buck Rogers, okay? And he had Buxcom, and if anybody's ever heard of Buxcom antennas and stuff like that, a lot of us have bought a lot of the off-center fed Wyndhams from him. He had awesome stuff, and I got to be pretty good friends with him. After I'd been going to Lynchburg a lot, I found out that his business was like 6 miles away from where I stayed. So on weekends, when I had a little bit of time, I'd run over to his place. And he was an old Marine, very opinionated. I got a lot of stories about Buck, but however, the last time I talked to him, when I called and he says, "Hang on just a minute, they're loading me in an ambulance." And I says, "I'll call you back later." No, I want to talk to you now. You know, that's the kind of guy he is.
Wow.
Anyway, yes.
But going back to the original question, you can set up an antenna that'll work, but you can probably make it work better with an appropriate balun.
Bingo.
That's where we're headed?
Yep, exactly.
It gets back to what Bob says. You set up your equipment and your radio and to balance that frequency to that channel, and then you don't have to worry about it. And when you start getting SWR, you know right where to look, those connections on the antenna or on your cable, and it makes a world of difference.
Exactly. What I was doing when I first started messing with it, I was going out there and adjusting my antenna to try to get it at 50 ohms here, and then, oh, it's not over here. When you know, when I'm a few little ways off, then I found out that there were devices that could make it look like it's 50 ohms, but it costs you a few bucks you could buy. So something like this gray box here, 119, 150 bucks, depending on where you buy it. I got the two toroids in there are probably 10 bucks, maybe 15. I probably got $5 in wire, and I think the connectors were maybe $3 or $4 a piece, and the box was like $8 or $9 over at Home Depot. So I saved a lot, I learned a lot, and I've probably made, well, I've had 20 toroids, and I think I've only got 2 or 3 left that are not in something. So at the bottom of my tower I got them, on my radios I got them, and so chokes and baluns are just something that works. Okay, so there's another toroid, and it's a transformer. You've seen those pictures of transformers over there before. Strap wire around it. But there's some unique ways of wrapping it. If you wrap the wires real close together versus far apart, you get different characteristics. Some schematics of different how to wire them. Some people can do it off of this. I'm one of those guys that love the colored pictures.
So can I ask a question right here? So you've got on the left, it says 100 ohm, but that's balanced.
That
And
would
on
be ladder line type.
Yeah.
Which is.
So that 2-to-1 balun.
Okay, you're saying balance between the two, okay, sides. So the right side, the 50 ohm. would be
Well,
your
on this
coax
side-
going to the radio.
On this side, there's just a
Yeah,
dipole, because dipoles are roughly 100 ohms. So you'd use a 200 ohm to one, or a 100 ohm to 50 ohm, or a 2-to-1 to bring it back down.
The coax is the unbalanced line going out to the
Right.
balanced antenna.
got it.
So you change the impedance and you change the ratio. Okay. So there's another balun. I've made several of those. Again, transformers. Now here's some other ways of doing things. And this is this. Okay, just got more turns in it. And I hate it. It just doesn't function like I want it. But you can take on the right side there, you can take a coffee can, which probably none of you have, but get you a can and you can take and wrap 8 or 10 loops around it, an 8-inch can on your HF radio, and that will do similar things. And you can do that up on your tower, or you can do it down where it goes into your house or wherever. And that's another way of using a choke to get noise, because the noise goes around and around, cancels itself out.
So I've heard, how do you know how many turns per frequency? Is there an equation for that, or is it just Google it, I guess, or what do you?
There might be. I've always heard people, some people are said it's gotta be eight
So for some people,
turns
say
on an
5.
8-inch diameter. The next guy you talk to, he has smaller wire and he's got a 4-inch diameter thing and he's wrapping it around and he only wants 4. And the next guy wants to have as many he can put on that thing because he's got cable that he wants to do something with.
But it has to be around a conductive material, like
No.
steel. Oh.
Nope.
It could be an
That's
airport.
PVC
Just wrap
pipe.
it around and take it off. That there's PVC, and I've got 2 of them that are just on, I think it's 4-inch PVC.
Sorry, one more question. Does that affect your SWR with inductance or
No.
anything that way, or it just
Nope.
takes out the noise?
Yep,
Steve,
yes.
so if you can go back to the previous, yeah, that one there. So the image on the left, so when I was trying to get rid of my RF interference on my 80 meter, when I wrapped it like that picture, it worked. But when I was not careful and it wasn't tight, it didn't work.
Bingo. What can happen when you're doing something like this is, in order to get it tight, and it worked better tight, right?
Substantially better.
What happens when you pull coax tight?
It breaks it up.
They have a bend ratio.
Mm-hmm.
And if you exceed that bend ratio, the conductor on the inside moves. Your impedance is different. That cable's no longer 50 ohms theoretically. So that's why I don't like it, because it's only useful if you loose wrap it. Because if you tight wrap it, that cable's done for the most part. May work, may not, but I've not had good luck with it. But I even bought special cable that was supposed to be super flexible.
So that's the advantage of using a larger diameter
Yes,
to avoid the tight wrap.
but
Bending the
but that's
cable.
1/2 inch diameter cable on the right side too. You wouldn't want to do that next to your radio. Maybe you will, but it's probably wouldn't be a bad idea. Okay, so does anybody recognize what that is?
Power cord filler.
Power cord, right? You just take your power cord, loop it through the toroid and back out again, and that will knock off garbage on your power going into your radio. And so you can put that. Matter of fact, are we running too long?
You said 5 hours.
Okay. So,
I'll make a donut run.
Or will he come back?
we don't have internet here, do we?
We do. It's just in this room, it's really weak.
Pardon?
In this room, it's really weak, but we do have internet in this building.
Okay. I won't show it then. This goes out to Palomar Engineering, and I got a lot of the pictures off of their website, and they sell you kits for stuff like this if you want to go to that extent, for your power cords, for your cables coming in, anything that hooks to your radio, they've got a fix for it.
Who's that? Palomar?
Palomar,
Palamar. Something
Yeah.
like that.
I think
Like
so.
Mount Palomar Observatory?
Nope.
Palomar? Or is there,
Palomar Engineering is what you said.
Steve?
Yes.
PalomarEngineering.com.
Palomar.
If you want to get on the internet.
Oh, you got it?
If you look for it on there, you should see it right now.
If we have time, we'll come back and get it, because there's a lot of useful information and pictures there that I was gonna show, but it's not the church one that came up though, because this will automatically hit that one, usually.
That comes up to being on this quick and keeps going.
And by the way, these are the people that I buy my toroids from.
So just so you know, if you call Palomar Engineering, you need to go through, I don't think all the vetting process, but they take down all your information. You have to create an account before they let you talk to anybody at all.
I don't talk to anybody.
Then you're the guy I would be talking to.
No, their engineers are high-paid people, and they want to know
Yep, they're all engineers.
if you're interested in buying, $1 million worth of their
That's
stuff.
right.
They're right there to help you.
Yep.
And you can't blame them, because amateur radio operators will beat a company to death. They'll put them out of business in a heartbeat, because they don't want to pay for anything, and they want everything. And that's why we have some businesses in town that will not deal with amateur radio operators, because they come in and they buy a connector, or maybe a dozen of them, and then come back the next day and say, these don't fit. Well, there's a special order. Well, I don't know, I want my money back. So they don't deal with it. Same thing with cables and stuff. I don't know if you ever had that issue or not, but
I know that business.
We thought about it.
It's on Utah Avenue.
yeah, a lot of people have been there before. But I work with Tony quite closely, and I understand the issues. And he wants to really work with amateur radio, but he will not do parts and bits and pieces, period.
Or installations.
That too, huh? If you wanted to put an antenna on your vehicle, was it Mountain
View?
Mountain Communication.
Mountain Land
He
Communications?
doesn't like to do ham radio.
He doesn't like to do it? Well, he had Steve Galbraith doing it, so.
The body shop.
Like he said, he didn't like
Broadway
doing it.
Ford
He had Steve Galvin do it.
Yeah, well, Steve worked for him for a while.
Yeah. If you want to pay them what they normally charge for commercial, they do it, but it'd be a couple $100 or more for a simple installation.
Yep. Okay, so chokes are designed to diminish unwanted signals or noise. Common mode chokes are also used as balance and work by eliminating common mode signals. Dipoles, these are just different kinds of wire antennas. Dipoles are usually a 2-to-1 current balance. Windhams are 4-to-1. And here again, depends on the height of these antennas. A Windham at 35 feet works great on a 4-to-1. But if you bump it up to 50 feet, it needs a 6-to-1, okay? They work better that way. Loops, they vary depending on the length and the height. Random wire, the same way, end-fed antennas and beverage antennas.
Where does the J-pole fit in there?
Pardon?
Where does the J-pole fit in there?
We'll talk about that in a minute. You're talking about a DI.
Bishop Storehouse
Yep,
J-pole.
okay, we'll talk about that. So Yagis, you're all familiar with that. They've got a reflector, a driven element, reflector, driven element, and then directors. And so those can be anywhere from 10 to 40 ohms, depending on whose you buy. Okay? So you got to know what you need there. And a common fix for that, we'll talk about a common fix for that in a minute here. So here's another Yagi with 20 to 25 ohms. They use a gamma match. And they may know what a gamma match is. We'll talk about a gamma match. You know what a gamma match is, and you don't know it. Does that look like a
That's a gamma match.
antenna over there on the right?
Mhm.
This doesn't show the top of it. Well, where does the RF signal come in?
On the driven element.
There's a gamma match. Yep.
So it comes in on that, comes in, and then it matches up with the 440 and also with the 2 meter, right?
Totally.
That's a sort of a gamma match.
It
Okay.
comes in the air. It goes out into your radio and goes out of your radio into the antenna and into the air. We need to change that.
I need to change this?
No, your
Oh.
speech.
Oh. So on a Yagi or anything else, here's a gamma match right here. And it's this little rod that runs parallel with that. That's the gamma match in the system that we use for the J-poles. I quite frankly had never heard it called a gamma match before, but look at it, it's a gamma match. And then I got to dig it around, and now I found people say it's a gamma match.
So I guess it's just Is that because both signals come in, one's a half wave and one's a quarter wave, and then they kind of match each other out, and so it helps reduce that, or I guess how does that work?
No, whatever you transmit on the driver there, if it's 440, it'll link into the short one real easy. If it's 2 meters, it's going to link into the taller one real easy.
In other words, where it's just auto-selecting, it just
It
doesn't
just
need to worry
does it.
about
Yep.
Okay.
It's kind of like you can take a dipole that's cut for 80 meters in this direction, put 2 more wires on it in this direction, cut for 40 meters, and you can tie these 2 together to a connector, and these 2 together to a connector, so which one's it going to work on? All 4 wires? No, when you run 80 meters, it only runs on this one. You run 40, it only runs on these. Okay? Adjusting your SWR. Here again, you can play around with your antenna, or you can put a tuner in its place. I prefer to make your antenna the best you can, either manually adjusting things or using Baluns or whatever, and then put some chokes on it to make sure it's what it is. So several years ago, on my loop antenna, I had a 4-to-1 Balun because people said, "Oh, loops require 4-to-1 Baluns." Okay, and so, but it was noisy. It was the noisiest antenna I have, and to transmit was lousy, but it could hear pretty well. Just heard a lot of noise too. So there's a lot of trade-offs there, right? Want to listen to a lot of loud noise and a little bit of signal, that's good. So I got to playing around with it, and so I put a 1-to-1 choke on it, coming right off the leads. And then I put a 2-to-1 Balun on it to get it to 50 ohms. And the thing sounds beautiful. Then I raised it up another 5 feet.
Yeah, yep.
Okay?
Yep, been there, done that.
Okay? Now it's down right now, but when it goes back up, I've got to deal with doing some more changes. So, okay, so here's some other examples. Vertical antennas with a feed point impedance less than 50 ohms, so it's 25 ohms. You're going to need a 2-to-1 Unen, so you want to go from 25 ohms to 50 ohms. Again, that's a transformer, right? For a vertical antenna with an impedance greater than 50 ohms, you'll need to step up the impedance. So it'll be 100 ohms to 50 ohms. So it'll be a 2-to-1 Unen. Excuse me. Okay, feed line chokes suppress the common mode current on the outside of the coax line. The feed line choke acts as a stop sign for RF, and won't let it go on out. And the higher the choking resistance, or it says resistance, but it's impedance. So the higher that impedance is, the less noise you're going to have on your line. No more, no.
So, comment, so when I was wrestling with this noise on my 80-meter antenna, and you were giving me advice what to do, and I was trying all these different things, and I have very high-end, was it R400 or
R400.
Yeah, cable.
Yes.
And then I had a cheap cable, and that got rid of all the noise.
Yep.
And you explained to me because the cheap cable was doing what all these chokes were doing, because the high quality cable was getting receiving all the noise, because that's what it does.
Well, signal loss in a cable. So the signal loss is in a cable, but in a bad cable or a poorer cable, lower quality cable, there's so much attenuation in there that you've got not much power going out, and you got not much coming back as a reflection, and there's not much coming back to cause you any issues, but it can be more noisy. Okay? Now, having said that, if you use LMR 400 or some of the other, higher end cables, it doesn't have any attenuation built into it to speak of, maybe a dB. 3 dB is half power, right? And some of these might have 6 or 8 dB of attenuation, the low quality stuff. The higher quality maybe only has a dB, so it's not even noticeable. So all that stuff comes back and causes you problems. So what's the answer to that?
Call Steve.
Try 21 different things.
Well, one thing is put the LMR 400 on your 2-meter antenna
Yeah,
and
it
your
works
70,
great.
and it works awesome.
Yes.
Okay? If you put the low quality cable on your 2-meter and 70 centimeter, nobody can hear you and you can't hear them unless you put a lot of power in it because it's lost. Turns out to be heat. And then you put the low quality on for your HF, and you don't hear very well, and they don't hear you very well, but it works. Turn up the power, heat the line up, melt some snow. But putting balance where they need to be and putting chokes will really make a big difference. Yes.
So you could have already covered this, I'm sorry I walked in a little late, but how do you know to choose, how do you know you need a 4-to-1, or how do you know off of your SWR, is that what you're looking at, or what are you looking at when you're tuning to be able to know what size and what type of turns ratio you'll need?
Well, I'm being sarcastic here, okay? Sometimes, and it goes against all of us' will and desire and interest, look in the manual. Sometimes they'll say it requires a 4-to-1 Balun, or sometimes it just doesn't tell you. And so if your SWR is really high,
So you kind of have to play with it a little bit.
yeah, you need to figure out.
Other things close.
But there's some generalities about, like a dipole that's cut to a frequency like 80 meters. That's almost always going to be 100 ohms. So you need a 2-to-1 Balun. A Wyndham at 34 feet is almost always going to be 4-to-1. There's just some generalities that people have experimented with that work.
Is there SWR meters that can actually measure your, resistance on the antenna? Does that make sense? Like if you're
It just gives you,
because it just gives you the SWR. There's not.
that's all it gives you. Yep. So, yeah, looking in a manual or getting online and finding somebody's got a similar antenna and see what they're doing.
I got you.
And probably 98% of the people aren't doing anything. And then I wonder why they can't talk to their neighbor. So, yeah, one thing I have done to mine that's been a problem is by making it a little bit better. I've got some neighbors that really hurt my ears when they whisper in their microphone because I don't have that loss that I used to have. So you're one of the culprits. Bubba's the other culprit, and Chris up on the foothills, and you're one of them. Yeah. I shouldn't be pointing out to people. You're not one of them.
Just a thing to clarify. If you have a piece of coaxial cable and you use your DCO meter, you can find out that it's pretty much 0 ohms along the conductor end to end and from one end of the shield to the other.
Yes.
But when we're talking about ohms for Baluns and stuff, you're talking about AC at some frequency. So your DC multimeter won't tell you. It'll tell you if your cable is shorted or not.
Yep.
Which I got one that was intermittently shorted, even a commercial one, and something you should check. But you can't use that kind of instrument when we're talking about these sorts of
That's right.
things, because they're AC and
That's
they're
right.
at some frequency.
Now, having said that, are you familiar with the copper J-pole antennas?
I think so.
Okay.
I have an
Made out of
arrow.
copper
So,
water pipe. They
it's
look
got
somewhat similar to the
half-inch pipe. It's like 57 and a half inches on one,
Yeah.
19 and a half on the other. Then it's got an elbow at the bottom, comes into a T. It's all soldered together. So if you measure it here and measure it up here, it's 2 meters. So using an ohm meter, if you will, doesn't do it, but an SWR meter will. It'll tell you. So, okay, a couple of other things that some of you may have heard popping on your HF radios, and that's the static coming in on the antenna, and it builds up on the antenna or your tower. So I've come up with a number of different things, and this is not one, but it looks like this. I thought I brought one, but so I just took and put inside of it, maybe this is one, no, this is 50 ohms, like a 10K ohm resistor between the ground and the shield on a connector, and then screwed it onto a T. In this particular case, I have a coil. For DC, as you know, DC will travel through a coil, doesn't see anything, it just goes through the coil, right? So I can bleed off noise, and it doesn't affect my RF coming through here. It just bleeds that stuff off, and you can stop the crackling. So I've had to make a couple of different ones because on my radio, I use 2 different channels, and one's listening on a vertical antenna and one's listening on a horizontal antenna. And the vertical one is always picking up more static because wind blows across it more, right? And it's a little bit more susceptible to that. So, but the other one has issues too with crackling. So you put these puppies on there, and then it makes Roger come through even louder. I need to talk to you about how you got your system set up because it's awesome. Pardon?
It's just the way this luck just happens. I don't know what
See,
happened.
that's the way it works. What else have I got? That's here's a typical Balun. I took the ears off of it. Normally they have some kind of ear on them, whether it's that or a couple of these eye hooks. This had eye hooks in it, but this is a 4-to-1 Balun or 9-to-1, 6-to-1 Balun. So sometimes I take them apart to see what's in them.
NFED.
Uh-huh.
I oftentimes heard them using like a 49-to-1. Is that
Yes.
to balance that out so that it looks like a dipole?
Yep.
To your radio.
Yep, because you've got one line going, theoretically you've got a ground, and then you've got, in a box, you've got a Balun in it, a 9-to-1 Balun. Then it goes out to a little choke. It's about 6 or 8 feet out, and then the wire just goes out wherever. So they work pretty good. Matter of fact, I'm seeing more people use NFED antennas, random wire sort of things, and getting really good responses. And I know Tamara here, she's got an NFED, right? And it's kind of surprised her because she just loops it around because she's hiding it from her neighbors. So I also know that there was a fellow that I talked to the other day that lights up his rain gutters. And he's got rain gutters on 3 sides of his house. And he says he's got a cable that he runs between the different things, and it actually works for different frequencies very well. So, lives in California. I don't know if he's still got his rain gutters up or not.
He still has them or not.
Any other questions?
How about the electric fence noise? How do you take that out?
With a shotgun.
Insulated wire fence.
Popping on.
I don't know.
Just take them.
You know, you can try putting some chokes and stuff on it and see what happens. It should help. Some radios have got a circuit in them that'll take repetitive signals like that out, and that might be an option. they inhabited the field behind me, the fields behind me. Craig moved in back there, and he took all the electric fences and stuff out. We're
Is
gone
that why
now.
our radios got so noisy? I didn't know he moved in there.
Yeah. So.
Come on, I'll put the electric fences back in.
Yes.
There's many ways to approach problems with antennas, transmission lines, and things like that. And I always make it a point to start with the antenna.
Exactly.
And go after the standing wave ratio of that antenna and your height of that antenna, and then look at what kind of feed line am I going to feed it with, and then start working for the transformers and the balun.
Yep. And that's the way to do it. It's, you know what your radio is, or what it should be. And if you buy good quality cable, you know what you've got, whether it's got a lot of attenuation in it or whether it doesn't. And so you know those things, those are fixed. As long as you've got good connectors, definitely go after the antenna first. Get it, make it the best that you can, and go the rest of the way. Any other questions? If not, we'll.
I just have a comment.
Yes.
I don't use a radio to talk to my neighbors.
There you go, I like that.
He doesn't use the radio to talk to his neighbors.
He just texts.
Say, hey, make sure I'm good, okay?
Well, Roger here lives over in this area. Well,
Yeah, pretty close.
pretty close to this area. I live out in Ammon. He lives on, well, about a block from me.
Yeah.
And this other guy lives about 5 or 6 houses from me. And the other guy lives up on a hill, so, yeah.
How come I don't bother you?
You are awfully quiet.
How do I come in? Loud, you come in loud on mine.
Do
Yeah.
I?
Yeah.
How do I come in compared to Roger? We're only a block apart.
Nowhere near like him.
Really?
Yes.
You know Steve Galvin? He lives at the conventions of a, he lives out in the middle of the Lavins. And he can hear and transmit and like no other.
Trees. Property out there
Yeah,
or
he's
something.
got magical property.
Well, on the HF net on Sunday evening,
Yeah.
on the HF net on Sunday evening, I listen to all, I can pick up almost all the people that check in. But when it gets to Idaho Falls,
Yeah.
I have to turn it off. Sometimes I'll turn on one of my 991s and then listen on just, actually I listen on my 2-meter antenna, and I can hear you. I can hear Bob and Bob.
I can hear Holly without any antenna.
Well, a lot of times she runs without an antenna.
I've heard her in Wilson, Wyoming. Really?
So Holly's loud?
When she's got a window open.
Well, I'll tell you, it hurts my ears. And quite often I'll have I've got a thing, don't take this wrong, but I got what's called a Roger that I can plug into my radio, and I can walk anywhere around.
Come on, shut down.
But I don't do that anymore. But I'd really like to know what kind of antenna you got. Is it vertical, horizontal?
That's vertical.
Well, it sure works.
You're talking about it on HF?
Yeah.
Oh, okay.
Yeah, HF.
Okay.
On the net on Sunday night.
Okay.
I need to take your antenna and move it out to Steve Galbraith. He has a fantastic ground.
He does.
He's right next to the river, and there's high subwater. He probably could drill down 2 feet and hit subwater.
Yep.
Wow.
No. Okay. There are no more questions.
Go through the ground a ways, get up to the antenna.
Back to Holly or Tammy or whatever.
The lady with no antenna.
The lady who doesn't need an antenna.
It's true, it works. You live a block apart. Hasn't burned up the radio yet. so. Steve, thank you. This has been amazing. Thank you.
Thanks for coming out.